And if I use now our numerical results, and I solve for you that quadratic equation, two equations with two unknowns, then I find that QP, you may want to check that at home, is about 6.6 times 10 to the 3 kilometers. It means it's only 200 kilometers above the Earth's surface. At that low altitude, this orbit will not last very long, and the satellite will re-enter into the Earth atmosphere. And it leads to a speed at point P, at perigee, of 10.7 kilometers per second. My second solution then is that QA turns out to be huge. No surprise, because we know that the semi-major axis is 50,000 kilometers. We find 9.3 times 10 to the 4 kilometers. And we find for V of A, this value is 14 times larger than this one, and so the velocity will be 14 times smaller. I think it's 0.75 kilometers per second. Yes, that's what it is. Immediate result of the conservation of angular momentum, that the product of QP and VP must be the same as QA times VA. That's immediate consequence of the conservation of angular momentum. And when I add this up, QA plus QP, I better find 2A, which in our case is about 100,000 kilometers, because A was 50,000 kilometers, so when you add these two up, you must find very close to 100,000, and indeed you do. So now we know everything there is to be known about this ellipse, and that came from the initial conditions from the 4 numbers that I gave you. We know the period, we know where apogee is, we know where perigee is, we know the orbital period, anything we want to know.